So, the rate of diffusion is determined by 4 different factors. Now, the 4 factors are the steepness of the concentration gradient, and that steepness of concentration gradient is determined by the difference between your high concentration and your low concentration. So if you have your high concentration here, so this is concentration 1, and that is greater than concentration 2. So you have a high concentration here and a low concentration here. That's a steep concentration gradient. If you have, now that's a big difference, for example. If your concentration 1 is just greater than your concentration gradient in concentration 2, so you have here versus here, that is not as steep. So that is not a steep concentration gradient. That is a shallow concentration gradient. So we will have movement from an area of high concentration to an area of low concentration in both cases, but this will increase the rate of diffusion. So the rate of diffusion will be from high to low rapidly, more rapidly from here to here than from here to here. So how high is your high concentration versus your low concentration? That is the key determinant. Steepness of the concentration gradient. Now, the next factor that determines the rate of diffusion is temperature. Because diffusion is a measure of the movement of particles thanks to their kinetic energy. The movement of particles down a concentration gradient by diffusion is determined by their kinetic energy. Having a greater kinetic energy, as measured by temperature, will only serve to increase the rate of diffusion. So, molecules that move faster will travel faster. If you are in a car traveling at 30 miles an hour on a straight road with no lights, you will get to a destination faster if you traveled on the same road with no lights at 60 miles an hour. The temperature is the same way. If you are at 40 degrees Celsius, you are going to get there faster than you would if you were at 20 degrees Celsius. So higher temperature gives you more kinetic energy. More kinetic energy increases your rate of diffusion. Surface area. Now, surface area is going to increase your rate of diffusion if you can only move through this space, then you are limited in what can pass through by the amount of space, by the surface area of the space that you can cross through. So this is the surface area you have for diffusion. However, if you have less surface area for diffusion, suddenly only this many particles can move across the membrane at any given time. So, with greater surface area, more molecules may cross a membrane, if it is larger, at any given moment. So that is how surface area contributes to the rate of diffusion. So a greater surface area means a faster rate of diffusion, by an increased rate of diffusion, because more molecules may cross at a time. Now the type of molecule or ion that is diffusing, that matters as well. If the molecule's size is increased, a larger molecule, you know what? Let's see if I can get this to be darker. A molecule that is larger versus a molecule that is smaller, if they have the same kinetic energy is a matter of force. So force is equal to mass times acceleration. If this has a greater mass, the acceleration will be lower. So this will have lower speeds. That means diffusion, which is a measure of distance over time, speed, will be lower. So that means that larger particles, larger molecules will diffuse slower than smaller molecules. small molecules will diffuse slowly. Small molecules will diffuse quickly, and large molecules will diffuse slowly. So, but what about when we're discussing an actual membrane? So a partially permeable membrane, if a small molecule is charged, so if it has an ion, if it is an ion, for example, and the large molecule is neutrally charged or non-polar, then this large molecule stands a better chance of being able to cross a non-polar plasma membrane barrier than does this charged polar molecule. A polar molecule will not cross a plasma membrane without a